Hello, everybody. I'm always amazed at how much bigger the rooms look from up here than they do back there usually, and the number of people. I'm Jeff Szczepanski with Stack Overflow. I'm actually going to talk a little bit about a technical topic for me, which is different than a lot of the talks I do. And in fact, one of my favorite questions in like the different business talks that I do is asking who might be familiar with Stack Overflow, because a lot of people aren't, even though it's kind of a big site to the development world. So it's kind of a boring question maybe to ask in this room. I'm guessing that how many people here are familiar with Stack Overflow. But so maybe we can say how many people use Stack Overflow this month? Raise a hand. Awesome. How about this week? Doing pretty good. Today? Not too bad. Have a browser tab up right this very minute on your phone or laptop? Hey, we got a couple there. That's good. Well, hopefully my talk won't send everybody else to Stack Overflow. Today, if you saw in the program, the title was a little different, but I promise you this is the same talk. It's a talk about scaling software development and kind of what to think about in terms of scaling the organization, but also scaling the product and how the product evolves, and basically some things to think about relative to minimizing technical debt and just sort of the dynamics of what I call here, you can see on the title slide, sort of this Agile Waterfall Continuum. But before I do that, just give you a little bit more background on me. As I mentioned, I'm the business guy or chief operating officer at Stack Overflow, which means I'm in charge of monetization. You know, this whole success of Stack Overflow, I wish I could take credit for most of what you guys are familiar with from a daily use standpoint. That's not me, although I do have a development background. Electrical engineer by training from college many years ago now. But I spent the first sort of 20 years of my career doing embedded software development, hardware design, chip design, voice over IP stuff, a lot of low-level software development. At a couple major companies first, but then a couple startups of my own with a couple exits there before getting to Stack. So a lot of years running some very large software organizations, or actually product development organizations, including hardware, software development, both desktop, embedded, mobile, all of that stuff. It's like a CTO and VP of engineering kind of roles. So that's my background there. Where's it go? So the first part to start off here relative to this talk is exploring a little bit about technical debt and what we mean by that. I'm assuming most of you are familiar with the term, of course. And sort of the properties of this, or what people normally think of. Technical debt can cause schedule slips, need to refactor things, sort of difficult to ship features you want to ship. Adding new developers doesn't speed things up, might be another symptom of it, a good symptom of actually probably technical debt, or maybe even sort of process debt, sometimes I might call that. Having buggy code, frequent regressions in the code, meaning stuff gets broken. Ongoing performance or stability problems, things don't work. You know, maybe Twitter, the fail whale, a classic case of a massive amount of technical debt. Perhaps due to success, but still a platform that really struggled to do well for a significant period of time. Slow turnaround of bug fixes. Bugs seem to be hard to fix. And really my all-time favorite, which is bug fixes for your bug fixes. And sort of tied into that notion of regressions. And you know, I think we've seen, depending where you guys are in your career, each one of you, you know, these things rear their heads at different points in different parts of the life cycle in the project. So I kind of want to talk about not really specifically how to eliminate this kind of technical debt, although it's certainly related, but I'm going to argue that there's actually really kind of two kinds of technical debt. And it's the second one that it's actually usually the most costly to a lot of teams, and maybe a little bit harder to deal with, and is maybe the core part of what I will be alluding to in a lot of this talk here. This other kind gets into basically when you ship something, version 1.0 of your code, and then you get to version 2.0 of the application, success in the marketplace, keep moving along. Version 3.0. The real question is, how much of the code's getting tossed away when you make these changes? And maybe more importantly, because this is expensive, right? You develop all this code and then need to do, implement the next set of features or wherever you're going in your roadmap. Throwing away stuff is expensive. So the real question I like to poke at is how much tossing away of this code is actually unavoidable. In other words, how much of this is good engineering and just the fact of the real world, or maybe engineering or system design that could be done differently or better to keep a smoother development lifecycle going. And so this technical definition, or a more generalized one, I think, is really a misalignment of what's easy to do with your code, either because of these sort of implementation issues or because of more architectural issues, maybe. What's hard to do with your code and your data to get it to where you want to go in the marketplace. Any sort of gap between it being smoothly and easy to progress through your roadmap is really the kind of technical debt that I really think is the most interesting. And this sort of cycle, just to kind of put it in graphical form here of what we're talking about, is usually when we ship stuff and we get a little bit of early success, it's pretty easy. The code base is small, the team's small, things are just getting started. You have a nice sort of in the A here on the graph, nice linear progress in features and functionality going out the door pretty reliably. But at some point, due to success usually, or just evolving feature set, you get to what I usually call the hot coals of development, which is that it starts getting very rocky to do stuff, and there's sort of this unstable development cycle, and gets into the first kind of technical debt that I talked about, but then also arguing that the root cause of this is really the other kind of technical debt, or certainly that's the harder one to solve. And if you either, hopefully you actually figure this out and then start growing again as the organization scales, but in a lot of times, software sort of becomes dead, or it has to be completely thrown away and rewritten. And that's the very, very thing that talking about trying to avoid here. And maybe how to think about that from a process standpoint of what's really going on here in terms of this being foreseeable, and what can you do about it from an engineering standpoint. One of the claims I'm going to make, actually, this technical debt is not just about the bad implementation kinds of things, or suboptimal programming at the construction level, but really is just, especially with some of the modern ways of developing, I guess I'll say, it's becoming more and more common that it's pretty easy to do fast iteration of things and be compelled by your customers to ship certain features and functions, but perhaps to neglect some of the architectural things. And I'll talk about that a little bit more in terms of maybe the way Agile works, things like that. So in effect, the whole idea here is to think about and talk about how do we get this smooth transition, avoid the hot coals, and right from the beginning, in a sense, or very early on, set yourselves up so feature and really whole product quality maintains high in the secondary definition of technical debt through the entire life cycle of your application development or product development. So one sort of tagline thing, tweetable moment, if you will, is sort of, I really like to think of key to scaling your applications is bringing the customers and their data and whatever type of product that you have smoothly along on the product roadmap. And this gets into not only defining that roadmap and having one, but then also being able to really execute it well from a technical implementation standpoint. So let's talk about software process a little bit, as I alluded to. Very common religious debates. Certainly through the course of my career, everybody argues things from tabs versus spaces, which, by the way, if you saw a blog post that we did, our data scientists did a study, a bunch of Stack Overflow users, and actually figured out through our talent business, part of the stuff that I run on a daily basis for the platform for hiring developers, that developers that use spaces actually get paid more than developers that use tabs. I happen to be on the other side of that, so maybe I wasn't a well-paid developer, but that's a different story, I guess. But anyway, anything from tabs versus spaces in terms of sort of religious wars in programming, which is a little bit more trivial, and to things like, for example, everyone agrees, right, that Agile, good, right? This is the way of the world. This is the way things work now. Those old people, like tall Jeff up here, more Waterfall-like thinkers, Waterfall bad. That's the old guy's way of doing it. Nobody would want to develop software like that anymore. And this is the thing that I kind of want to challenge a bit. And I'm not going to get up here and certainly say that everybody should go to full-blown Waterfall. That's not the point. But I do want to explore this space a little bit more in terms of what's really going on here when we think about software development processes. So if you indulge me for a minute, these are kind of off the top of my head, and I'm sure everybody's going to have their own sort of list here. But let's talk about some good properties of Agile development. First and foremost, I think this is the biggest one, not well comprehended, perhaps earlier in the life cycle of learning how to do software development, but admitting that requirements evolve is sort of a very important aspect of Agile. Encouraging regular releases. We have these defined places through the sprints. We're trying to push stuff out, check things in, test it out. The fact that that's actually kind of part of the thinking, very important property of Agile. This, of course, then allows validation of progress more often so you can check in and really see where you're at. Just because we coded it doesn't necessarily mean it's done. So presumably, if we get through the sprints, implement, test, close that loop, this is a good thing. We understand that we're sort of are where we think we are in terms of developing. The sprints and just this whole concept is excellent for driving what I call cadence in a team, which is the pace at which we're moving through, which is a very important element when we talk about that smooth ramping curve of and avoiding the hot coals. We want to move continuously and smoothly through that product roadmap or feature deployment and stuff. So this idea that sprints are there and that we have a time clock, in a sense, for cadence via the sprints is super important and a great property of Agile. Retrospectives, the whole retrospective concept in Agile I think is great because it brings in a formal notion of learning, closing the feedback loop. And then, of course, not exactly all upsides to Agile, I think. Maybe not formally with the way it's processed, the way the process is actually defined, but I think maybe more commonly the way it's implemented. Some people poke at this one a little bit with me and say, well, Jeff, that's not technically part of what Agile is all about. But I think in common practice, and that's really what it comes down to in the end, pitfalls of Agile, at least on most teams that I work with or see, either through our portfolio and some of the VCs that we're associated with, a lot of different startups, mid-sized companies, big companies that I used to consult with in the olden days. Scheduling and the notion of structured planning out into the future with hard dates well into the future seems really rare in Agile. Implicitly encourages feature-centric thinking, I think. The idea that you have the backlog and the list of features and that people are sort of organizing those and prioritizing those on a very dynamic basis. Could argue it's an upside, but I'm going to also say that that's sort of a downside there because this basically comes at the expense of good system design, which is what I think starts to get at the heart of one of the more insidious forms of technical debt. The incremental nature in general, I think, which just encourages shortcuts in how we plan and do things. My favorite, sort of quote from software developers sometimes is either like, we better hurry up and start coding, there's going to be a lot of bugs to fix, or stuff like, why bother planning that out? It's going to, why put time into the schedule or planning the schedule out? We'll just put that time into the code and get done faster, which for me is very much like saying we're going to build a very tall building, why bother digging a foundation for it? That just makes the building taller and take longer to build. Obviously, some problems in there. And I think that's another core limitation of or pitfall of Agile as commonly practiced. And then just in general, because of this sort of fast move sprints, we're trying to get stuff done. We push code kind of mentality, which has its advantages. It just sort of leads to lighter specs. It's documented by the code. What do the data structures look like? It's in the code. Things like that, which I think are sort of problematic. So overall, I think that the overall undertone of Agile in a lot of ways, as implemented in most teams that I see, is that why plan or document things too much in detail when it's just going to change as you implement the next feature and refactor this thing or deploy that other thing. Now, of course, we can now look at Waterfall and do the same kind of analysis. Formal specifications rule. This idea that there's a formalism to different parts of the detailed planning, actually doing requirements analysis, for example, actually doing system design. In fact, I think that might be my next bullet there. System design specifically a thing, right? Like in other words, in Waterfall, if we talked about the Waterfall process, we would see these stages of software development, and they're going to be very explicit about doing market analysis, customer requirements, customer specifications, technical specs, coding, test plans, the whole thing. That's all done in advance in a sense. It's highly efficient actually to develop in Waterfall if you actually know what it is that you're going to build and you have people that know how to practice the software, discipline of software development well. There's really no better way. You can go straight to the finish line in theory if you know exactly what it is that you're trying to do. The pitfalls, of course, in Waterfall, requirements never are really perfect, right? Customer doesn't know what they want, maybe, didn't do the analysis right, didn't capture it right, things are overlooked. That's actually not well comprehended in Waterfall. It encourages actually long serial release cycles because of this, waterfall nature, cascading effect of the different stages, which works against what we talked about in Agile with the sort of common checkpoints. So this whole idea of spec everything, design everything, build everything, test everything, problems are discovered late, and the further down you get, obviously, the more costly that is. So not ideal across the board. But what's really interesting in this observation, if you didn't kind of get to there already on your own, is that the pitfalls of Agile are pretty much the strengths of Waterfall. And the strengths of Agile are pretty much the pitfalls of Waterfall. So you really kind of see them in a continuum, which gets back to exactly what I was saying around the title of this talk right here. And this is what I actually like to call the Agile Waterfall Continuum, actually. And this idea that if you're, in a sense, trying to decide how you are structuring and deploying process and development methodology through the life cycle of your product, you actually got to think about this dial, perhaps actually starting off much more agile, but then over time actually making its way over once you understand product market fit and knowing better exactly what it is you're going to build and the customer discovery aspects are gelled better. You actually have to start turning this dial towards the waterfall direction as you scale up. Put together a little, hopefully this comes up okay on the slide there. Actually, to think about this continuum a little bit in more detail, I drew this thing here where we have the vertical axis, which talks about the dial basically being set. At the bottom, we have a pure agile development team. Up at the top here, we're saying we're operating pure waterfall. And you can see up here, I say, I don't know what I put on here. This is like a Joel Szczepanski thing, actually, I think I stole. Basically, crocodiles and alligators in this land up here. If you try to go absolutely pure waterfall, for the reasons that we talked about in the pitfalls there, you're going to be in trouble. And I think if you go, to the wall, extreme agile, or extreme programming, I used to work with that guy, don't listen to that book. The extreme programming type stuff, also crocodiles and alligators down here. And what you're really doing when you turn that dial is thinking about where do you want to set the dial on the vertical axis based on, in a sense, there's going to be multiple dimensions to this picture here really, but in this simplification of it, I talk about simpler systems, smaller applications, smaller teams in a sense, at this end of the axis, and then complex systems over here on the right. And you can see that we basically, these two quadrants over here, if you're very waterfall, and you're in simple system land, right? You're kind of the architecture astronauts doing a lot of process without a lot of value over here. If you're in the other part of it where you have more complex, bigger systems, bigger teams, and you're more pure agile, you're in Refactorville and Bug City, I'm going to complain. And this is where you're going to struggle on the other side. So you really want to be in these quadrants over here that has something to do with sort of the applications and where you're deploying. I talk about stable, large team development over here on the more sort of complex end, more waterfallish than not. Embedded system design, the world that I used to live in for doing, even like iPhones or something like that. Anything that's an embedded product with embedded software. These are going to have much longer cycles and be much more waterfall oriented. Maybe not at the micro level, but certainly at that sort of mid level within the scaling of the project. In other words, Apple does an iOS release every year, right, or something like that, and going along with the iPhones and the platform. So embedded systems development. And then you can say stable small teams, I think, can live down here where you're pretty agile and operating simpler systems or smaller teams in a sense down here. And anyway, like I said, that's an oversimplification, but this is something that kind of helped with where it's at. I'm somehow making fun of Access software development over here. This kind of, building on top of existing tools with simpler languages, macro languages, programming in Excel kind of stuff, or Access. You can certainly live, more in that area of the curve over there, so to speak. So To get a little more specific about what's really going on here at a little bit deeper level, a little less sort of superficial treatment of this maybe. What are the actual variables that we're looking to consider in addition to what I already outlined in terms of how you're structuring your teams and where to set that dial, or what are the variables that go into setting that dial. So the length of the release cycles, how long of a release cycle do you have, I think is a really important dynamic. The longer they're going to go, for whatever reason, we have to start thinking about setting the dial based on that sort of dynamic. What are the clarity and confidence in the requirements? This is where, early on I was alluding to, earlier software projects tend to be more agile because you need to do those validation exercises. You need to ship stuff just to find out if you're even building the right thing, which ties into the release cycles as well. But that clarity and confidence in customer requirements is a very important aspect to consider. Because the better you understand this and the more mature your platform is, in a sense, you're going to want to start thinking a lot more waterfall-like to make sure that the underlying system design and architecture is being abstracted in a way that maps to the model of the way your customer thinks about the world, not the way you kind of tend to want to think about the technology or the code base. How complex of systems are we building? Are we putting people on the moon or launching rockets, or are we developing a web app for programmer Q&A? Much simpler application, at least. Maybe in the Stack Overflow case, if it wasn't such a large scale operation in terms of the 40 million users a month that we get on that site. But overall, certainly at that end of the complexity scale versus the rocket launching cases. How catastrophic are defects? The agile stuff tends to really get in the way of this particular aspect. Need much more formal analysis and validation, planning, specification, test stuff. If you're doing, I don't know, I guess pacemakers, maybe the rocket launches again is a good one, versus, somebody's not going to get their question answered this morning, although that seems to be a hot button on Twitter when we do go down, if and when we go down. Size of the software team and the customer base, right? I love to think of Apple and iPhones. It blows my mind when you think about Apple from a hardware and software standpoint of how many million phones have already been built. And we'll be shipping like iPhone 8 soon with all that software development on there. Really, they have in a sense, defects there are catastrophic as well, either in terms of dollars if it's hardware, or just literally millions and millions of users who are going to be very unhappy if anything goes wrong there. And at their kind of scale, it's amazing to see how again, certainly things happen with a complex and very large customer base, complex product and very large customer base, but mistakes are super, super costly there, just because of the size of the customer base and the massive number of people they have working on it. So anyway, those are kind of the knobs in there, and I do longer forms of this kind of analysis and working sessions with people, so we can't cover everything in detail, but one of the ones I wanted to talk a little bit more about is just why scheduling is so important, because I see so many teams that really bypass scheduling and structured planning with roadmaps and stuff. And so I kind of want to give a pitch to that because I think that's specifically tied into this. And actually, no matter where you set that dial, just the idea that you have schedules and you put the investment into them is super important in my mind, especially as you scale. And it seems like a lot of teams get the habits of the very agile end, where it's pretty easy to fast iterate, push stuff, move very quickly, not worry about the planning, high level of trust in the team, all those kind of things. But that starts to change, and you have to really shake that in the culture of the teams. And in fact, Stack Overflow, us as a company and development organization, actually struggled with this for a while, sort of midway through the life cycle of the last 7 or 8 years, where things really have to change as the teams get a lot bigger. And all the things that used to hold near and dear to your heart, start to collapse, basically. And the question is how quickly do you realize and shed those things of the past and really adopt and understand why those things are actually causing you problems. So schedules is the one that always seems to be the most controversial for whatever reason, or people just want to focus on the code rather than the sort of operational aspects of software development. And so the first one that's maybe kind of obvious is sales, marketing, support, customers. What do we promise them? And it depends on your market. And some markets with free software, you have more flexibility. Stack Overflow's always had this luxury, I guess, that we never have to promise specific hard dates around things and stuff like that for a lot of cases. But I'm going to argue they're actually still really important from an internal standpoint. But anyway, that's one reason you want to have schedules. The next reason is that if you're actually trying to make roadmap decisions, and do I do feature A versus feature B, or going after customer segment versus A versus customer segment B, how can you make trade-offs if you actually don't know the cost of what it is that you're trying to implement? In other words, good business decisions, the software engineering organization or engineering in general and product development, in a sense, owes it to the business teams of the company, assuming you're there to make money doing something, to be able to put price tags on things. And for the most part, software development, price tag is based on how long it's going to take. And then this is actually the most important one. And for me, the really salient reason why it's actually essentially not optional in any team I've ever run, not to have very strict scheduling and planning anywhere beyond that very early MVP stage, is because if you think about it, when you're doing software development, how do you know you're doing it well? How do you know you're moving along efficiently? What do you use to understand whether you need to improve something in your software development processes? What's the canary, if you will, in the coal mine that's the hinting of what is going on? I'm going to argue that the schedule and the idea that if you can be predictable, first predictable but then fast, the way you actually understand the quality of your code base and the proficiency of your engineering team is actually to be able to put together accurate schedules over a long period of time. It's that sophistication and validation of that loop that is really the one and only thing that allows you to completely close the loop on quality. Bugs and how many bugs get discovered in testing versus in the field and different stages in your development process hint to these kinds of things, but I'll argue that the absolute best indicator you can have is actually predictability and scheduling relative to how you're actually doing as a software organization. Which is, if you want a better one in the future, then you need to use tools of some kind, including schedules, I think, to help gauge that. Let's see how we're doing on time here. We got a couple minutes. So lots of skills at play. Again, we could talk about this all day if you wanted to in terms of different things going on. But I think the next point I'm going to make is you want to get more sophisticated around quality software development and doing it really well and being predictable and having that smooth roadmap over time and with quality, is understanding there's a whole bunch of different skills that need to be implemented on the team. And we sort of maybe take this for granted a little bit, but that's one of the reasons that software development is hard, is because so many different things are at play, whether it's just the skill of discovering and finalizing requirements, system architecture, design, the actual coding and coding construction, discovering bugs, how do you use a debugger, how do you fix things, estimation itself in product management's another skill in there. All the deployment related things, does what you coded actually make it into the field the way you expected? Can you track bugs, all these kind of things? All these different skills are there. And the question is, how formally are we writing these lists of skills down and then figuring out that we need to develop those in people and actually say how good is person A versus B versus C at these different types of things, in a sense. You need to put that operational structure in around the team rather than, earlier on, which works, where you either hire really good people and they just already kind of know what to do, or certainly as you're scaling, you're bringing new people, more junior people on the team, broader diversity of experience base and context. You got to figure out how to align and arraign all these things in. And so just understanding and appreciating that all of that stuff is there and putting some formalism around it is super helpful and important. So, and another one that I don't want to miss there is even the morale aspect, motivating people on the team, keeping them engaged, having them being happy about being developers. Some of it's about free coffee and free lunch and things like that, but a lot of people are there to build a great technical product. How do you drive that cadence, maintain consistent commitment and engagement of people on the team? Also a really important aspect. So when we talk about this organizationally, kind of bring it down to home a little bit on our teams at Stack, and certainly all through my career. In fact, we even do this within sales, but that's a whole nother sort of agile waterfall type properties, thinking about how sales teams are run. But there's really kind of three key roles to think about in terms of how you structure teams to accomplish this, I'm going to claim. And of course, you have the developers that are actually the people with all these skills that I'm talking about that actually have to implement the code, who are the primary contributors building the product at the implementation level, certainly. And then I like to define a formal team lead role with a very specific aspect to it. Of course, we've all heard of dev leads and team leads, But one of the things that I wanted to call out this, and something that we focus on very specifically, is that one thing that's really important around a team lead that's distinct from an engineering manager is that they're both a player and a coach. And in a sense, these should be your strongest sort of role models on the team. You could point at that person and say, that's exactly the kind of software developer I want to hire. That's exactly the type of software developer I would like everybody on the team to be. You want somebody to be designated at that and engaged in doing that. And also within a team, the team lead, I think, has a very specific role, which, in an Agile context, we may talk about it as the person who runs the stand-ups, but it's not necessarily has to be the same person. But there's somebody that's in charge of cadence specifically, monitoring the morale and the engagement of the team, and is sort of the cheerleader or champion of actually moving things at a certain rate, and in a sense communicating with the next third most important, I guess, on the team, I'll say, is the engineering managers. So you have team leads who are kind of eyes and ears for sales managers, or engineering managers. And these engineering managers, these are not like the architects or the decision makers from a technical standpoint. What they really are is they should be experienced software people, but what they're focused on is not the development of the code, but actually that skill development in the people. So they're the ones taking the systematic approach to the long-term growth of the people on the team, while the team leads are the ones responsible for, in a sense, getting it out the door on a daily basis, getting things out the door timely. And so to kind of highlight this a little bit more in terms of what we're actually talking about there, in this role separation between team leads and engineering managers, I like to talk about it as, if you think of racing, car racing, you got the tracks going, or the cars going around the track. These are your software developers working together, trying to get stuff out the door. The pit crew, who's there daily on the radio, working with the team directly as the race is being run and we're shipping stuff, that's your team leads. They're the ones monitoring the sort of heartbeat or cadence of the car, if you will, on the track. And the engineering managers are more like the garage mechanics. They're the ones that are going to overhaul the engine, work on the suspension, design new configurations and stuff of the car, which is your team. That role separation is really, really important in terms of having the engineering managers focused on that. And in a sense, you have team leads that are thinking about day-to-day, basically, and being a walking personification as both a contributor on the team and that team lead driving cadence, working hand in hand with the engineering managers who are really about skills development and really understanding where everybody on the team is actually at from an overall reliability and skills standpoint, in a sense, to mix the metaphor there. So, in summary, minimizing technical debt is about matching your code base and your data to your market, basically. And you really have to think of that as the overall goal of actually what you're trying to do to keep that technical debt at a minimum, so you have the smoothest process and predictability moving forward about how to drive features, functionality into the application, into the marketplace, basically. This idea that predictability is highly correlating to quality, and that I'll argue that you can only really have a predictable team, especially one that's moving fast, if your code quality, system quality, technical debt is low, quality is high. This I didn't get into a lot, but also understanding this idea that performance and results aren't the same thing. This is the idea that you might win or lose a race in a given day, but the question is, how are you doing overall from a process capability standpoint, sort of the long run versus the short run. Results day to day is different from how well the team internally is actually performing in a long run basis. Keeping those things separated, understanding, much like the cadence and the skill development separated, that the actual performance and quality factors are actually independent of day-to-day results. Even great teams ship bugs every once in a while. And so you want to look at that in the right context. And once again, isolate cadence from skills development is a really important one. So overall, the ultimate goal is developing that strong suite of skills in each one of the developers. And in the end, it's that ability of those developers to do those things that's obviously going to drive the overall ability to ship code timely and effectively with high quality. Thank you. Let's see, I think we have at least a few minutes, right, for questions. If people had them, you can, 10 minutes? Okay, great. Wow. if we have that many. You can ask me anything you like about the presentation, about Stack Overflow, what I used to do growing up, sailing actually in a nice city, kind of like Hamburg, on the other side of the world though. Anybody? Questions? Must be at least one. Nobody wants to know what Joel eats for lunch every day or something? There's one over there.
Thanks for the nice talk. So you clarified finally this tabs versus spaces discussion. So I'd like to know, is it Emacs versus Vim?
That's a great question, actually. Raquel, I don't know if I can't see you right now, but if you're here, write that one down. We'll maybe get the data team on that. I forget exactly how it actually came up with tabs versus spaces study. We're obviously analyzing our data all the time. The interesting thing about Stack Overflow is that we obviously have all these developers in the world coming to the site every day. We do a massive developer survey, which our salary data is mostly based on, and stuff from our job listings for the talent platform for companies that can hire programmers off of Stack Overflow. And so I think they sort of tripped over it in the data as a curiosity. Dr. Dave, he's got a big Twitter following, who's one of our data scientists, kind of looked into it and actually figured out that it was statistically significant. And we can debate why it exactly happens, but at least as sampled with our data set, there is a very clear correlation there. So yeah, the Emacs VI one, that's a great one. I'm a VI user, just for the record on that one, but I know a lot of people are not. That's a good one. Anybody else? Quiet crowd. Did I talk too fast? Sorry, I'm a New Yorker. Okay, well, that's easy. If nobody else has any. Thank you very much. I really appreciate it.